Welcome to this GCSE lesson on kinetic theory and gases. Before you start this lesson, you should already be able to describe how the motion of particles changes as temperature changes, describe the motion of particles in a gas, and state what is meant by the term pressure. Pressure and the particle model. Particles in a gas are free to move due to large spaces between the particles. If the gas is kept in a container, the particles will collide with the edges of the container. As they collide and bounce off the walls, they exert a force on that part of the wall. The more particles colliding with the wall every second, the greater the pressure. So as we can see in figure A, the particles, represented by the dark red dots, are traveling with different velocities, represented with these arrows. Their direction and the speed they're going is represented by the direction of the arrow and the length of that arrow. State the cause of pressure. Describe what pressure is affected by. Balanced pressure. On the Earth, we are under the constant pressure of the atmosphere. Trillions of air molecules are colliding with our bodies every second. To counteract, our bodies exert an outward pressure that is equal and opposite to the pressure of the atmosphere. If those pressures become unbalanced, i.e., no longer equal and opposite, we can be crushed or we can swell to a greater volume. Explain what will happen if the pressure on the outside of the human body is greater than the inside. We can perform an experiment to demonstrate this. Figure B and C show what happened to an aluminium can when the pressure inside is less than the pressure outside. A can with a small amount of water inside is heated to the boiling point of water. The water vapor pushes out the air. When the water vapor is rapidly cooled, it condenses back into a liquid. Then, the pressure inside will be less than the outside, and so the pressure of the air molecules colliding with the outside of the can crushes it. Explain why the can will collapse. Increasing pressure. Pressure can be increased in two different ways. Increasing the temperature of the gas, which is shown in figure D, where the particles now have longer arrows representing their velocity, and increasing the number of particles in a container. By increasing the temperature of a gas, it causes the particles to move faster. This means that they will collide with the walls more often. It also means when they do collide with the wall, they will do so with a greater force. By increasing the number of particles in the container, it increases the number that will collide with the walls every second. State the two factors which affect pressure. Explain how the number of particles in a container affects pressure. And explain how temperature affects pressure. So how do we know that gases are made of tiny particles that are moving around randomly? So the particles in a gas are too small to see. However, scientists know that they exist and that their motion is random because of an experiment by a scientist named Robert Brown. He was looking under a microscope at pollen, where he noticed the tiny pollen particles would seem to move randomly changing direction. By placing a very small particle that is large enough to see, as shown in figure F, you can see the effects of random collisions, shown in figure G. Einstein later published a paper explaining this Brownian motion. This can be seen using pollen or any other object which is small enough to be affected by individual collisions, but large enough to see with a microscope. So what was happening is these pollen grains were randomly changing direction because they were being collided with by the atoms in the fluid. This caused it to appear to change direction out of nowhere. However, it was actually due to very, very small particles colliding with the pollen. Describe Brownian motion and explain the cause of Brownian motion. If you'd like to attempt some further questions, having read through the textbook page, you may do so.